shark bite, and then we're going to go over the 6 graphing and solution questions that you're supposed to do by today. So with number 1, translate the following. This should be 4x or whatever variable you used minus 6, all of that being squared. Questions on that one? Number 2, you needed to combine like terms, so distribute the 4 and the negative 2. Multiply those. Combine your x's together to get 10x. Combine your constants together to get 18. Questions on that one? Number 3, you needed to evaluate. Put in negative 3 where all of your x's are. So when you do that, you would have negative 3 squared plus 2 times negative 3, or 9 minus 6, which becomes 3. So f of negative 3 equals 3, or f of x equals 3. Questions on that one? Number 4, we needed to find the slope between these 2 points. So you would subtract your y's together, 4 minus 4, then subtract your x's, 4 minus a negative 3. The 4 minus 4 would give you 0. The 4 minus negative 3 would give you positive 7. But 0 divided by anything is 0, so your slope would be 0. What questions do we have on that one? For the very last one, the easiest way to do this, since we're looking for a line whose slope is negative 2/3 and goes through this point, is start at this point, negative 2/4, and go, or do your slope. So up 2 to the left 3, down 2 to the right 3 as many times as possible. That would be the easiest method, and I say that because if you try to use that point in your slope and find the y-intercept, you would end up with something that is a fraction, as you can see here. It's not on a whole number. So you could do it that way and then try to graph it that way, but it may be a little bit more complex than you actually want it to be. Have any questions on that one? Right. On those notes from last class, starting with number 1, I'm just going to read through your solutions. Also, these solutions are written different than how we were. As long as you have these solutions, you're good. If you don't have the solution, maybe your graph was drawn incorrectly, so you would need to go back and fix that at a later time, not at this moment. So number 1 had 2 solutions, negative 5 and 1. Questions on number 1? Number 2 had 1 solution. It was at 1, 0. These are also given to you in the table, so you can look there as well. This only touched the x-axis once. What questions do we have on that one? Number 3, this did not cross the x-axis at all, so this had no solution. on number 3. On the back, for number 4, we have 2 solutions at 2, 0 and 8, 0. Questions on that? Number 5, you also had 2 solutions at negative 3, 0 and 3, 0. Questions on that one? And then the very last one, you have 2 solutions again at 0, 0 and 2, 0. Questions on that one?
Does there have to be a y value of 0 to have a solution? For a day off school tomorrow, does the y value have to be 0 to be a solution? Nobody wants a day off? Not really. I like it. Yes or no? Y value is always 0 for a solution.
Yes. No. Yes. No. Maybe so. Who knows?
That doesn't make me feel very safe there. Yes, forever and ever and ever. The y value of a solution is 0. Always 0. Y value 0.
In those same set of notes, find this page. This is the last thing we have to talk about regarding roots. Okay, so with this, we're still finding the roots of the graph, but we are going to write it a little differently. So for number 1, what would the root of this be? I mean, your roots and your solutions, your x-intercepts. Negative 4, 0, and 2, 0. So I could say that this is really x equals negative 4 and x equals 2. So when we write this, we're going to write this in factored form. What I mean by that is when we were factoring, we would get answers at the end. They would be factors. Had we taken it a step further and solved those factors, we would get solutions. In order to write these solutions as factors, we need to take whatever is given and do the opposite with them. What I mean by that is, instead of writing x plus or x minus 4, we're going to write x plus 4. Instead of writing x plus 2, we're going to write x minus 2. The reason we do them backwards is this. If we had both of these equations and we set them equal to 0, so I'm going to do this off to the side. We had both equations, we set them equal to 0, and we started to solve. If we subtract 4 here, we get x equals negative 4, which is our solution. We do the same thing here and add 2. We get x equals 2, which is our solution. So in order to put it in factored form, we need the opposite sign. So when you do this, if you haven't done this already, the 2 concatenates 4 the roots and zeros, the zeros of polynomials factored form, and zero product property. These two will help you a lot with that, or this will help you a lot with that. Last thing with this, so now that we have our factors, we want to find our original equation. We don't have that yet. So we are going to distribute this, kind of like when we were trying to find, do our factors work? Did we get the original equation? We're going to go back and do that method. So we're going to take x and multiply it to everything here. X times x would give us x squared. X times negative 2 would give us negative 2x. Then we're going to do the same thing to the others. So take 4 and multiply it here. Four times x would give us positive 4x. 4 times negative 2 would give us negative 8. Then we could combine like terms to get our final answer. So y equals x squared plus 2x minus 8. If we put this or both in our calculator and graph it, it would match this. They would also overlap if you put both in. Before we start number 2, do we have any questions on anything from number 1? What are your 2 solutions for number 2? It does kind of look like that, but there are 2. 8, 0 is one of them. And 7, 0. So if we were writing these as factored form, what would those 2 be? X minus 7 and x minus 8. You're always taking the sign, making it the opposite, and putting x in front of it. Okay, we're going to start distributing this, and I don't know if we'll have time to finish this or not. This is about Livingston. So distributing this out, we have y equals x squared minus 8x. And then minus 7x plus 56. We'll do the final answer when we get back from lunch. We're having a lunch group. Also, you can look at 7th grade. Alright, let's finish this problem. So the last thing we need to do here is just combine the terms. So y equals x squared minus 15x plus 56. Do we have any questions on how we find the factors, get it in factored form, distribute, or find our final quadratic equation? If not, take the next 5 minutes and do numbers 3 and 4, and then we'll go over those after that. The answers 2, 3, and 4. Your factored form was x plus 8, x plus 3. And your final equation, y equals x squared plus 11x plus 24. For number 4, your factored form was x plus 1, x minus 5. And your final answer was y equals x squared minus 4x minus 5. What questions do we have on either of those? We are now going to switch gears and look at the notes that were sitting on your desk when you came in, the quadratic formula. You want a copy of that? Okay, so this is the last thing that we need to learn about for this unit. So we talked about solving quadratics using the square root. We also talked about, no we didn't. Something we did not talk about is solving by factoring. So like last unit when we were factoring, we could have taken that a step further, factored, and then solve those factors to get solutions. We're not doing that. You'll do that in Algebra 2, those of you moving on to that. But so the square root method only works if you don't have a b term. The factoring method works only if you can factor. If you can't do either of those things, then the only other way to really solve this is using the quadratic formula. Remembering this or knowing this would be helpful for you for the quiz and tests, but it will also be given to you. So do you have to remember it right now? No. Those of you moving on to Algebra 2, you will need to know it and remember it to use it for the future. But we're going to be using this formula. The very first thing we need to do, and again, if you didn't grab your calculator, make sure you have it. So for all of these problems, the very first thing we're going to do is label what our A, B, and C values are. Remember that we can find those from this quadratic equation. What would your A value be? 4. A is the number in front of x squared.
1.
Your B value?
6.
Negative 6. And your C value? 4. You're going to do that for every single one of these. Label your A, B, and C's. Once we have those 3, we're going to use the quadratic formula.
Always a number. Never the variable. Don't get confused. Don't ever think it's x. It's always a number. If nothing in front of the x is 1. Or if it's a negative x, it's negative 1.
Okay. So we're going to do this example using these and using our formula. So the very first thing we need to do is start to set it up. So x equals, we have a negative b, so it's always going to be negative, no matter if it's negative or not. And then plus or minus. So when I say that, I mean the symbols combined. The square root of whatever b is, put that in parentheses, negative or positive, and we're going to square that. We're always subtracting this 4, and then we're multiplying our A value, here is 1, and our C value, which is 4. And this is all over 2 times our value of A, which is 1. After you have this originally set up, we're going to start to simplify. So next, this negative and this negative would combine to become a positive 6. The plus or minus would stay. Negative 6 times negative 6 would become a positive 36 underneath the square root. Keep your subtraction sign and multiply these three numbers together. So disregard the minus. 4 times 1 times 4 would be 16. And then 2 times 1 would be 2. Now we can simplify it some more. (36 minus 16 would give us 20. At this point, sometimes you'll be able to simplify this more, sometimes you won't. But we're going to look at this number, see what it is. This number is called your discriminant. You'll hear more about that in Algebra 2. That number helps you determine how many solutions you'll have, but you'll deal more with that in Algebra 2. For us, we just need to see, is this discriminant number a perfect square or not? Is 20 a perfect square? What times what gives you 20? So they have to be the same number. 20 is not a perfect square. Because it's not a perfect square, we are not going to take the square root of this number. We're not going to get the decimals. We're going to leave it as is. In Algebra 2, you will go on to simplify this more. We are not doing that. So what we are going to do is take this and separate out the plus and the minus. So we'd have x equals 6 minus the square root of 20 over 2. And 6 plus the square root of 20 all over 2. So whatever that plus or minus is, we're separating them into two different solutions. And then our very last thing we're going to do is write it as a solution set in our curly brackets. We can't simplify this more without separating the fraction. So if we separated it, it would be 6 over 2 minus the square root of 20 over 2. We don't want to get into all of that. So this is as simplified as this is going to get. And that would be our solution set. Before we move on to the next one, what questions do we have on this? This is something new, so make sure everyone is trying this. Let's move on to number 1. We're going to do the same thing. So let's first list our A, B, and C values. A is 1, B is 10, and C is okay. Then we can take those values and start putting it into our formula. X equals negative B, but our B is positive here, so it would just be negative 10. Plus or minus the square root of B squared. So even though it's positive, still put it in parentheses. That way you get used to doing that. Minus 4 times our A value of 1 times our C value of negative 2.
Wait, why is it 4?
In the formula, it's just 4.
Oh, right.
All over 2 times your A value, which is 1. In this next step, I'm going to show you how you can simplify this a little bit quicker than what we did in the first example. If you would like to keep doing all of this, so simplifying to this part and then this part, that's fine. What I'm going to do is go from the first step to this step in the calculator. I'm going to take everything inside here and put that in the calculator. So not the actual square root, but just the numbers. So in parentheses, 10 squared minus 4, make sure it's minus, not negative, times 1 times negative 2. Make sure that one is a negative and not a minus. You can put that all in at the same time. And that would tell you your discriminant a little faster. Is 108 a perfect square?
No.
No, it's not. And if you're not sure, put it in your calculator, see if you get a whole number or not. So the square root of 108 is a decimal, so no, it's not. So that means this answer is going to be very similar to what we did up there. I'm going to skip this middle step and just go to my solution set. Because I'll have my minus and my plus. So negative 10 minus the square root of 108 over 2. And negative 10 plus the square root of 108 over 2. So these would be two solutions somewhere on the x-axis that they would cross, but we don't need to find exactly where that is. Do we have any questions on this so far? We are going to get to some examples where you simplify more, but this next one is not going to be that. Starting with number 2. With number 2, this is not in the same format, so we have to change it first. We're going to move this 4x over by subtracting it, doing the opposite of whatever it says. So when I put this here, I'm not actually subtracting x squared to negative 4x or negative 11 to negative 4x. I'm just moving it to the other side. Equals 0. Now that it's in that format that we've been seeing, now we can find our A, B, and C values. What are those? 1, negative 4, and negative 11. So now that we have those values, we can start putting them into our formula. So x equals negative b, but b is already negative, plus or minus the square root of b squared minus 4 times your a times your c. All over 2 times a. There is, there are 2 different songs. They're actually the same song, but one's a slow, one's a fast version of this formula to help you remember it. I'm not going to sing it, but you could look that up if you wanted to know a way to remember this. Then we can put this inside our calculator, figure out what that number is. Negative 4 squared minus 4. Times 1 times negative 11 is 60, a perfect square. No. So this will look just like this. We have x equals, simplify this because this would become a positive 4 plus or minus the square root of 60 all over 2. And then your two solutions, or your solution set, would be x equals 4 minus the square root of 60 over 2, and 4 plus the square root of 60 over 2. Okay. Colin?
Doesn't matter which order you put the negative and positive.
I would say do it least to greatest. Even though you don't know what these are, subtracting something would be less than adding something.
So always minus.
Always minus first. You may see that the order doesn't matter on certain things like Delta Math, Khan Academy, and practice. But just for our sake, let's put minus first. Other questions on that one?
Remember, every time you square something, it's always going to be positive, right? 2 negatives, positive, 2 positives, positive. So that first step under the radical, always a positive number when you square it.
Okay, let's move on to number 3. Same thing. We need to move the 20 over. So again, I'm not actually subtracting it to either of these, I'm just moving it to the left. So we have x squared minus 8x minus 20. What are the a, b, and c values? One, negative 8, and negative 20. And then we can put this into our formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Find your discriminant number. Yes. Is 144 a perfect square?
Yes.
Yes. So the way we were doing this before is going to be different for this problem. Because the square root of 144 is what?
12.
12. We're going to have 8 plus or minus 12 over 2. Which means we're still going to have two solutions, but we're going to have either whole numbers or fractions when we simplify this. So let's do that. We would have, let's separate this, 8 minus 12 over 2 and 8 plus 12 over 2. Simplify those both. You can do it all at the same time or separately, does not matter. 8 minus 12 would give us negative 4. 8 plus 12 would give us 20. simplify again, and we would get our final answers for our solution. I'm going to put this over here. So negative 2 and positive 10 would be our final answers or our final solutions. So we know for certain that this quadratic would cross the x-axis at negative 2 and 10. What questions do we have on this? Let's do some more. For number 4, what are our A, B, and C values?
1, -5, -36.
1, -5, and -36. So then we can put those numbers into our formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Start to simplify and find your discriminant. What would that number be? What would that discriminant number be? 169. Is that a perfect square?
Yes.
Yes. The square root of 169 is what? 13. So we have 5 plus or minus 13 over 2. And then we can start to simplify this more, separate it into 2. So x equals 5 minus 13 over 2 and 5 plus 13 over 2. So x equals negative 8 over 2 and 18 over 2. So then our solutions would be x equals negative 4 and positive 9. Questions on this one? So when you get a perfect square, you have to do a little bit more work. Me personally, I like it when it simplifies nicely like this. Because when it doesn't, I'm like, did I do this right? Are these numbers right? Let's do number 5. What are your A, B, C values? 1, 6, and 10. And we can put these into our formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's see. Start to simplify and find your discriminant.
-4.
-4. Can we take the square root of a negative number? No. So when you get to something like this, your solution should be none. You cannot take the square root of a negative number. You could try. Let's say you're not sure, or you know that 4 is a perfect square, but then you put in the negative and it would tell you it's a non-real answer. That would tell you this entire thing is going to be a solution, which means your quadratic would not cross your x-axis at all. Do we have any questions on that one? We're going to do just a few more.
You get the negative under the radical, that's nice, and you can stop working right immediately.
Let's do number 7. What are your A, B, and C values? You're so close. The 7 and the -3 are your B and C, but your A value here is -1. So when we do this, we have to remember that our A value is -1 and that we put in that -1. So x equals plus or minus the square root. I'm sorry, I messed this up already. Hold on. X equals -b plus or minus the square root. There we go. B squared minus 4 times your A, which is now -1, times C, all over 2 times A, which is now -1. Start to simplify. What would your discriminant be?
37.
37. Is that a perfect square? Is 37 a perfect square? No. So our solution set is going to be this in the negative version. So x equals -7 minus the square root of 37. All over 2, -2. And -7 plus the square root of 37 over -2. Questions on that one? Do number 11. Our A, B, and C values are what? 2, 5, and 4. So don't assume that your A value is always going to be 1. It could change. It could be negative, it could be positive, it could be something big, something small. And start doing your formula. negative b plus or minus the square root of b squared minus 4 times a, which is now 2, times c, all over 2 times a, which is now 2. Start to simplify, and what would your discriminant number be? Negative 7. What would our next step be? So if we take the square root of negative 7, what would that be?
Oh.
That one will give you no solution. So you have to be able to recognize that, otherwise you may do something that you're not supposed to, still take the 7 but take the negative out. I don't know. You guys do weird things when it comes to the quiz and test. Let's do 13. For 13, what are our A, B, and C values? A is 2. There isn't a B at all, so that would be 0. And C would be negative B. So even though B is 0, or B is not there, we're still going to include it. We're going to use that 0 and still do this process and see what happens. So x equals negative 0 doesn't really make sense, but I'm going to write it because it was the formula. Plus or minus the square root of 0 squared minus 4 times 2 times negative 8. All over 2 times 2. Find your discriminant. 64. Even though this is 0, I'm going to keep bringing down that 0. You'll see why here in a second. So 0 plus or minus the square root of 64 over 4. Is 64 a perfect square? Yes. What is the square root of 64? We get 0 plus or minus 8 over 4. So our two equations, or two solutions, start to look like this. 0 plus, let's do minus this. 0 minus 8 over 4, and 0 plus 8 over 4. The reason we leave that 0 is to remind us what we're doing to the 8. That way we can simplify it. So this would become negative 8 over 4 and positive 8 over 4. Or negative 2 and 2. Questions on this one? We're going to do 14 and then we're going to start 16, but then I'll have you guys do that. So 14 will be our last one we do all the way. We first need to get 12x to the other side. So subtract it. not actually subtracting it to the side, but just moving it. So 4x squared minus 12x plus 9. What are your A, B, and C values? A here is what? 4. B here is negative 12. And C is 9. Okay, so start putting that into your formula. X equals negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. It should be a positive number.
0.
Should be 0. So x equals 12 plus or minus the square root of 0 over 8. What is the square root of 0? 0. So in this case, if I were to rewrite this, 12 plus or minus 0 isn't going to change my answer. It's going to be 12 over 8. Adding or subtracting a 0 is not going to change. Here, it did change because we had a positive and a negative, but here it does not. So we have 12 over 8. Simplified would be what? 3 over 2. This would only have one answer or one solution. So 3 over 2 would be your one solution. It would touch the x-axis once. Do we have any questions on this?
Guys, your notes are good. I was looking at your notes, and I highly recommend, I know I can be sloppy, is keep those A and C in parentheses so you know it's multiplication. 4 times A times C. And again, guys, your notes look very good, so I recommend continuing to do that when you're doing these on your own or in a quiz or test next week.
Right. The last thing for 16. So we're not going to solve this completely. We're just going to get everything on the same side. Because if you got something like this, you would need to do that first. Doesn't matter whether you move things to the left or to the right. Me personally, I like my x squared term to be positive. If you made it negative, that would be fine. Everything is on the right, so if you want to move everything over there, that's fine. Me personally, I'm going to move everything to the left just to keep my x squared term positive, but that does not matter. So I would subtract my x squared. I would add my 2x. And then I would, subtract 15 just to the other side. So looking at all of those things. 3x squared minus x squared would give me 2x squared. 7x plus 2x would give me plus 9x. And then I move my 15 over. So now it looks like normal, and we can find our A, B, and C value and use the formula and continue.
It's like you did the second problem on shark bite today, combining like terms. You gotta get that happening.
Right. So for the remainder of class, I want you to practice problems in this You could do one that has a perfect square. You could do one that doesn't have a perfect square. See if you could do some others. We are going to take the next class, so you have more time to practice this as well. But do use this time today to practice one or two. You may not get to two, but at least practice one with the time we have left. Anyone have questions on what we're doing for the rest of the class? Use this time wisely, practice this.